Modifying electrical equipment, specifically adding lugs to a main breaker in a motor control center, or MCC, typically requires manufacturer approval. The National Electrical Code, or NEC, addresses this requirement in several sections. Firstly, NEC 110.3b states that equipment intended to be used in accordance with this code shall be approved for the intended use. This means that any modification must not violate the original equipment's approval. Secondly, NEC 110.3c specifies that listed or labeled equipment shall be installed and used in accordance with any instructions included in the listing or labeling. Adding lugs could be considered a modification that affects the equipment's listing, making adherence to the manufacturer's instructions crucial. The manufacturer of the main breaker or the MCC will typically have specific instructions and requirements for modifying their equipment. These instructions are critical for maintaining safety and code compliance. The manufacturer's guidelines might include, firstly, approved methods for adding lugs, specifying the types of lugs that are compatible and the procedures for their installation. Secondly, torque specifications, which are precise tightening values for lug connections to ensure proper electrical contact and prevent overheating. Thirdly, wire size and type requirements detailing the appropriate conductors for the new subfeed based on ampacity and insulation ratings. Fourthly, testing and inspection procedures outlining the necessary steps to verify the integrity and safety of the modification after completion. Obtaining manufacturer approval is essential to ensure that the modification is safe and will not compromise the integrity or functionality of the equipment. It also provides documented evidence that the modification was performed according to the manufacturer's specifications, which is vital for liability and insurance purposes. Failure to obtain manufacturer approval could lead to several negative consequences. Firstly, it could void the warranty on the equipment, leaving you responsible for any future repairs or replacements. Secondly, it could create safety hazards such as overheating, electrical faults, or even fire, due to improper installation or incompatible components. Thirdly, it could result in code violations and potential fines or legal action from electrical inspectors or authorities having jurisdiction. As a best practice, it is always advisable to contact the manufacturer of the equipment to get specific instructions and approval before making any modifications. This proactive approach will help ensure that the modification is done correctly and safely, minimizing risks and ensuring compliance with all applicable codes and standards. When contacting the manufacturer, be prepared to provide detailed information about the existing equipment, including the manufacturer name, model number, and any relevant specifications. Also, clearly explain the intended modification and its purpose, providing drawings or diagrams if necessary. The manufacturer may require you to submit detailed plans for review or may send a representative to inspect the equipment before granting approval. Be patient and cooperative throughout the approval process, as it is in everyone's best interest to ensure the safety and reliability of the electrical system. Furthermore, when adding lugs, consider the following technical aspects to ensure proper installation. Firstly, select lugs that are specifically designed for the conductor size and type being used. Use dual-rated lugs when aluminum and copper conductors are married together. Secondly, ensure that the lugs are made of a material that is compatible with the conductor material to prevent corrosion. Thirdly, thoroughly clean the conductor and lug surfaces to remove any oxidation or debris that could impede electrical contact. Fourthly, apply an appropriate antioxidant compound to the conductor and lug surfaces to further prevent corrosion. Fifthly, use a calibrated torque wrench to tighten the lug connections to the manufacturer's specified torque value. Sixthly, after tightening the connections, visually inspect them to ensure that they are secure and properly seated. Seventhly, perform a thermal scan of the connections after the equipment has been energized to check for any signs of overheating. In addition to the NEC requirements and manufacturer's instructions, it is also essential to follow all applicable local codes and regulations when modifying electrical equipment. Local codes may have additional requirements or restrictions that must be followed. Contacting the local electrical inspector or building department can help ensure compliance with all applicable regulations. Modifying electrical equipment without proper knowledge and authorization can be extremely dangerous. It is always best to consult with a qualified electrician or electrical engineer before making any modifications to ensure that the work is done safely and in accordance with all applicable codes and standards. When working on electrical equipment, always follow proper safety procedures, including firstly, de-energizing the equipment before starting any work. Secondly, using appropriate personal protective equipment or PPE, such as safety glasses, gloves, and insulated tools. Thirdly, verifying that the equipment is de-energized using a voltage tester before touching any conductors. Fourthly, following lockout/tagout procedures to prevent accidental re-energization of the equipment. Fifthly, keeping the work area clean and organized to prevent accidents. Sixthly, never working alone. Having a qualified helper nearby can provide assistance and support in case of an emergency. Finally, if you are not comfortable or familiar with electrical work, do not attempt to do it yourself. Hire a qualified electrician to perform the work safely and correctly. In summary, modifying electrical equipment, such as adding lugs to a main breaker in an MCC, requires careful planning, adherence to manufacturer's instructions, and compliance with all applicable codes and standards. Obtaining manufacturer approval is crucial to ensure the safety and reliability of the equipment and to avoid potential warranty issues or code violations. Always consult with qualified professionals and follow proper safety procedures when working on electrical equipment to protect yourself and others from harm. Consider the specific application and load requirements when selecting the appropriate lug type and size. Different types of lugs are designed for different applications, such as mechanical lugs, compression lugs, and bolted lugs. Choose a lug that is rated for the conductor size, material, and ampacity required for the new subfeed. Also, consider the environmental conditions in which the lugs will be installed. If the equipment is located in a corrosive environment, select lugs that are made of corrosion-resistant materials, such as stainless steel or tin-plated copper. Furthermore, if the equipment is subject to vibration, use lugs that are designed to withstand vibration and prevent loosening. When installing lugs, ensure that they are properly torqued to the manufacturer's specifications. Over-tightening or under-tightening the lugs can both lead to problems. Over-tightening can damage the lug or conductor, while under-tightening can result in a loose connection, which can cause overheating and electrical faults. Use a calibrated torque wrench to ensure that the lugs are tightened to the correct torque value. After installing the lugs, inspect them regularly to ensure that they are still properly torqued and free from corrosion. Loose or corroded lugs can create a safety hazard and should be replaced immediately. Document all modifications made to the electrical equipment, including the date of the modification, the name of the person who performed the modification, the type of lugs used, and the torque values applied. This documentation will be helpful for future maintenance and troubleshooting. Keep the documentation in a safe and accessible location. Consider the impact of the modification on the overall electrical system. Adding a new subfeed can increase the load on the main breaker and other components in the system. Ensure that the existing equipment is adequately sized to handle the increased load. If necessary, upgrade the main breaker or other components to prevent overloading. Also, consider the impact of the modification on the system's grounding and bonding. Ensure that the new subfeed is properly grounded and bonded to prevent electrical shock hazards. Furthermore, consider the impact of the modification on the system's overcurrent protection. Ensure that the new subfeed is protected by appropriate overcurrent devices, such as circuit breakers or fuses, to prevent damage from overloads or short circuits. When selecting overcurrent devices, consider the ampacity of the conductors, the type of load being served, and the interrupting rating of the device. Coordinate the overcurrent devices to ensure that they trip in the correct sequence in the event of a fault. This will help to minimize the extent of the outage and prevent damage to equipment. Before energizing the modified equipment, test it thoroughly to ensure that it is working properly and safely. Use the multimeter to check the voltage and current levels on the new subfeed. Also, perform an insulation resistance test to verify that the insulation on the conductors is intact. If any problems are detected, troubleshoot them before energizing the equipment. After energizing the modified equipment, monitor it closely for any signs of overheating or other problems. Use a thermal scanner to check the temperature of the lugs, conductors, and other components. If any problems are detected, energize the equipment and troubleshoot them immediately. Provide training to personnel who will be operating or maintaining the modified equipment. The training should cover the proper operation of the equipment, the potential hazards, and the safety procedures to be followed. The training should also cover the location of the overcurrent devices and the procedures for resetting them in the event of a trip. Keep the training records in a safe and accessible location. Review the modification periodically to ensure that it is still meeting the needs of the facility and that it is still safe and reliable. If any changes are needed, make them promptly and document them accordingly. In addition to the technical aspects of modifying electrical equipment, it is also important to consider the legal and regulatory requirements. In many jurisdictions, a permit is required before making any modifications to electrical equipment. Obtain all necessary permits before starting any work. Also, comply with all applicable codes and standards, such as the NEC, the National Electrical Safety Code, or NEC, and any local codes or regulations. Failure to comply with these requirements can result in fines, legal action, or even criminal charges. Document all permits and inspections in a safe and accessible location. When working on electrical equipment in Maryland, be aware of the specific electrical codes and regulations that apply in that state. Maryland has adopted the NEC as its state electrical code, but there may be some local amendments or additions that must be followed. Contact the Maryland Department of Labor, Licensing and Regulation or the local electrical inspector for more information. Also, be aware of any licensing requirements for electricians in Maryland. Only licensed electricians are allowed to perform electrical work in the state. Ensure that the electrician you hire is properly licensed and insured. In conclusion, modifying electrical equipment is a complex process that requires careful planning, adherence to manufacturer's instructions, compliance with all applicable codes and standards, and a thorough understanding of electrical safety principles. By following these guidelines, you can help to ensure that the modification is done safely and correctly, minimizing risks and ensuring the long-term reliability of the electrical system. Also, consider hiring a qualified electrical engineer to review the modification and provide guidance. An electrical engineer can help to ensure that the modification is designed and installed in accordance with all applicable codes and standards. An electrical engineer can also perform calculations to verify that the existing equipment is adequately sized to handle the increased load and that the new subfeed is properly protected by overcurrent devices. Furthermore, an electrical engineer can provide documentation to support the modification and to demonstrate compliance with regulatory requirements. When selecting an electrical engineer, look for one who is licensed in the state where the work is being performed and who has experience with similar types of projects. Check the engineer's references and ask to see examples of their work. Ensure that the engineer has a good understanding of the NEC and other applicable codes and standards. Get a written proposal from the engineer that outlines the scope of work, the fees, and the schedule. Review the proposal carefully and ask any questions you may have before signing it. During the design and installation process, communicate regularly with the electrical engineer to ensure that the work is progressing as planned and that any problems are being addressed promptly. Keep the electrical engineer informed of any changes to the scope of work or the schedule. Document all communications with the electrical engineer and keep the documentation in a safe and accessible location. After the modification is complete, have the electrical engineer inspect the work and provide a written report. The report should document the results of the inspection and should identify any deficiencies that need to be corrected. Correct any deficiencies promptly and have the electrical engineer re-inspect the work to ensure that it is now compliant with all applicable codes and standards. Keep the electrical engineer's report in a safe and accessible location. By working with a qualified electrical engineer, you can help to ensure that the modification is done safely, correctly, and in accordance with all applicable codes and standards. This will minimize risks, ensure the long-term reliability of the electrical system, and protect the safety of personnel and property.